Welcome back. This is part 2 of section 2.3 on the algebra of functions. I have a new example here. If we want to let f of x be equal to 13x and g of x to be negative 2x minus 4, we want those different operations: sum, subtraction, multiplication, and division. So for the sum, f plus g of x, we're just adding these. 13x plus negative 2x minus 4. Adding these together would just make 11x minus 4. For f minus g of x, this would be 13x minus negative 2x minus 4. So we would have to make sure we distribute the negative throughout in the g of x function, but this would make 15x plus 4. For f times g of x, 13x times negative 2x minus 4. We would get negative 26x squared minus 52x when we multiply those out. And all three of these, the domain would be all real numbers, just like the original functions were. So the domain of this is just all real numbers. But when we would divide these, f divided by g of x, this would be 13x divided by negative 2x minus 4. And the only thing we can do is take out the negative in the denominator. This would be negative 13x divided by 2x plus 4 if we did that. And essentially the same thing. The only thing with this denominator, though, is that x cannot be the value of, in this case, negative 2. Because if we had negative 2, it makes 0 in the denominator. So the domain for this is negative infinity to negative 2, union negative 2 to infinity. So here's another example, example 5. Both the functions f of x is equal to 1 over x, and g of x would be 3 divided by x minus 5. We want the domain of f plus g, which means we first need to find that. F plus g of x. So 1 over x plus 3 divided by x minus 5. And the domain of this, since we have, again, the two fractions like before, x here cannot be 0, and x cannot be 5. Otherwise, we have those division by zeros. So the domain is negative infinity to 0, union 0 to 5, union 5 to infinity. All in parentheses, since we can't have that number in the denominator. If we let f of x be x squared plus 7x and g of x to be 5 minus x, we want f divided by g of x and then f divided by g of 4. So f divided by g of x would just simply be x squared plus 7x divided by 5 minus x. We could factor in the numerator, but that's not really going to simplify much of anything. For f divided by g of 4, we can put 4 in and see what happens. 4 squared plus 7 times 4, all divided by 5 minus 4. So 16 plus 28 divided by 1. This just means 44. For this next example, based on this graph, we want to find f times g of 1. So at the value of 1, f here is 1, and g is 3. So 1 times 3, this would give us a nice value here of just 3. And then finally, this last one. Let f of x be equal to x squared, g of x to be 3x plus 1 divided by 2, and h of x to be x plus 5. So multiplying f and g, this would be x squared times 3x plus 1 divided by 2. So distributing that x squared, we would have 3x cubed plus x squared, all divided by 2. And my cube there looks a little horrendous. Let me fix that. All right, h minus g of x. This would be x plus 5 minus 3x plus 1 divided by 2. We can simplify this a bit by doing a common denominator, in this case of 2, and rewriting this. Rewriting the x plus 5 with a denominator of 2, that'll be multiplying the numerator by 2. So this just becomes 2x plus 10 divided by 2, minus, not plus, minus 3x plus 1 over 2. So combining, this would make negative x plus 9 divided by 2. F plus h of x, this would just simply be x squared plus x plus 5. So just drop in those parentheses, we would have x squared plus x plus 5. For g divided by h of x, this would be 3x plus 1 divided by 2, all divided by x plus 5. We can flip this fraction just so we don't have the double fraction to be 3x plus 1 divided by, this would be 2 times x plus 5, so 2x plus 10. Let me know if you have any questions or concerns. Thank you.